Welcome. This is the Cisco CCNA ENSA, also known as the Enterprise Networking Security and Automation course. This course focuses on the CCNA version 7 curriculum. This is course 3 of 3. Module 10, Network Management. Alright, so in this lecture we're looking at device discovery using both CDP, LLDP. We're going to be looking at some management protocols like NTP, SNMP. We're going to be looking at how to work with syslog. We're going to be looking at file maintenance on both routers and switches. And we're going to end with some basic iOS image management. So let's jump right on in with network discovery using CDP. First of all, CDP is Cisco Discovery Protocol. It is a Cisco proprietary Layer 2 protocol which essentially basically just helps identify Cisco products. And how does it do this? It will send periodic CDP advertisements to connected devices, and basically these advertisements will share information about the type of device that's being discovered, the name, the number, and the types of interfaces, things like that. The goal here is to share basic information about the devices. So for Cisco devices, CDP is enabled by default because it's a Cisco device. How we can verify is show CDP. The interesting part is to turn it off per interface. We could do a no CDP enable in the interface configuration mode. So let's say we want to get rid of it underneath gig 01. Navigate to the interface, disable it. And if let's say you want to disable CDP as a general, you would be disabling CDP. If we want to be specific, we would do a no CDP run at the global configuration, and that would be the disable portion of it. How do we see the details? We could be doing a show CDP neighbor, and it will give you the device ID, the interface, the hold time, the platform, and the port that it's associated with. So if we want to look at specific details, you'd be a show CDP neighbors, and you'd tack in the detail command there as well. We have a lab covering how to do this using CDP. We actually have multiple labs in this chapter covering each one of these major areas. Next is using the link layer discovery protocol. If you've ever used Windows 7 or above, LLDP is there. It's a vendor-neutral neighbor discovery protocol, very similar to CDP, but it's more than just for networking devices. Though, in this example, we're focusing on networking devices. This protocol will advertise its identical and capacity to other devices, and it will receive the information from a physical connected layer 2 device. Again, we have to understand that both CDP and LLDP are layer 2 functionality. How do we configure it? Well, we have to do a little bit more with our LLDP. We actually have to navigate to the global configuration and the run command. This basically will allow us to enable it globally. To disable it, we would do no LLDP run, again from the global configuration. If we want to configure a specific interfaces, we'd have to configure both transmit and receive sections separately. We do that by navigating to the interface, going LLDP transmit, LLDP receive, and that ensures our transmission and our receiving. And they are these commands right here underneath our interface. How do we verify? Show LLDP neighbors, just like with CDP. If we want more specific details, we will be doing a show LLDP neighbors detail, just like CDP. Again, they're very similar in functionality. And again, we have a lab. This time we're looking at both CDP and LLDP. Next is going to be our network time protocol, time functionality. So if we want to sync time and calendar services, we're going to be using the network time protocol, NTP. We've talked about this in earlier sections, earlier videos, and earlier content, but again, time plays a huge role, especially when we are trying to synchronized like log management. So being able to set the time accordingly is extremely important. You can manually set the clock and date per device. However, if you manually do it, if the devices run a little slower, a little faster, the synchronization of the time can be off. So as the network grows, it definitely becomes more difficult. So a better solution is to use NTP and to set up network synchronization so that the time management is set to an NTP server. This will provide a consistent time setting regardless of the device. NTP uses UDP port 123. So how does this work? NTP uses a hierarchy system for time resources. Each level in the hierarchy is called a stratum. The stratum level is defined as the number of hops counting from the authoritative source, and a synchronized time is distributed across the network. So, normally the source, it could be a central time manager, it could be a Google time management server, it could be a government track time server. It really just depends. And then how many hops away from that would tell you how far you are away from the source. There are a hop count of 15 possible, so the lowest stratum number is 16. Normally you don't want it to be too far away from the stratum main groups. So normally we have a stratum 0. That's the authoritative time source. It has the highest precision time. We have a stratum 1. Basically, these devices directly connect to the authoritative time source, and they act as the primary network time. Anything less than stratum 2 are basically connected to stratum 1s for their time. Realistically, most government organizations, or like time management, time and TP, all of those are set to be a stratum 1. We users will connect to them, so we could be a stratum 2 or 3 or lower. If we are using a reference NTP, for example, we may connect to a time server management server that connects to a different time management server that connects to a different, and then connects to a different. That's how we can get the different stratums. So we may not be, number 2. We may be number 8 or number 9. But all of them sync back to a stratum 1, which connects back to a stratum 0. How do we verify? Well, from the exec mode, we can do a show clock detail, and that will give us our time. How do we configure an NTP server? Pretty straightforward. From the global configuration, NTP server, type in the address. And here it is right here, NTP server, type in the address, and that is where it will get its detailed information from. We can also see things like the association by doing a show NTP association or show NTP status. Basically, these will let us look at the address, the reference clock, the polling, the offsets, and all of the major details. The show NTP statistics will show us the stratum number as well as the reference and the frequency that it is actually dealing with. The big part here is we're looking at the precision of our time. Again, to set it, we would be doing NTP server, set the appropriate IP address, and then you can now look at the associations and the statuses. You'll notice here we're doing a nested NTP server, so instead of being the stratum 2 like it was before, we'll have a stratum 3 because we're now 3 hops away. And again, we definitely have a lab walking us through how to do all of this. And that is it for this module. If you got any questions or concerns, please reach out. Thank you.